industry. So it's really exciting to get everybody together to talk about our topic, which is demand forecasting. We have a couple of really amazing speakers who have been working their crystal ball for a really long time, and they're excited to share some of their experiences with you. To introduce myself, I'm Stephanie Bomey, and I'm a leader here at Newsot. Newsot is a focused data analytics consulting firm based out of Chicago, and we have some amazing experience helping organizations harness the power of data to really achieve their goals. So really excited for today. We do have a few housekeeping things. We will be recording this, and so if you don't want to be on video, now's your time to click that button and go off screen. And you will be muted throughout this entire presentation. We really encourage you to ask any questions. We'll have a dedicated Q&A at the end. You can use that chat function down there on the bottom right. It looks like a little text box. And afterwards, we'll definitely send out a link to the video so you can view it again. And we will send out your LinkedIn badges that you'll all receive for attending. It'll be about a few days before we'll get them out, but we'll get them to you in your email. So keep your eyes peeled for that. So with that, I'm going to hand the ball over to Ben and take it away.
Awesome. Thanks, Stephanie. Hey, everyone. My name is Ben Myers. I'm one of the leaders in the data and analytics practice at Newsot. I've been in data and analytics consulting my entire career, much of it at Newsot. I've been here coming up on 7 years now. And a fun fact about Newsot is while we touch the full spectrum of data and analytics, we started primarily as a forecasting company. And for the entire time that I've been at Newsot, I don't think we've ever had a period we weren't running at least one forecasting project. In that time, I've gotten to see processes that range from like capacity forecasting at big 5 tech companies to financial and market forecasts to supply chain and demand forecasting, which is where we're going to be focusing today. I've gotten to learn a lot about what works in forecasting processes and perhaps even more about what doesn't. And I'm really looking forward to being able to dive into you guys today. Tammy, why don't you introduce yourself next?
Yeah, hi everyone. I'm Tammy Waggoner. I lead our CPG and retail practice here at Newsot. I've been at Newsot for a few months, but I've worked with Newsot's leaders for almost 10 years as a client when I was at Hillshire and Tyson before coming here. So most recently, I was a VP of commercial capabilities at Tyson. So think anything related to food service and retail sales. Sales reporting and data, trade and CRM systems. Kind of germane to this conversation, customer service and related to demand, CRM, and customer experience. So I was also involved with many special projects around the supply chain, trying to solve some of the problems we're here to talk about today. So I would just add one comment. We really don't have a crystal ball, in case you were wondering, but we'll do our best. So with that, I'm going to turn it over to Ben to kick us off.
Awesome. Thanks, Tammy. So just to start, do a little bit of level setting. I want to start by talking through what are the typical steps that we see in a forecasting process, because I think understanding this helps understand where and how we tend to approach improving the process and gives an idea of where some of the weaknesses and gaps often come up. So in general, most forecasting processes start with the generation of a statistical forecast. That often comes from like a tool. It could come from your inventory system. It could come from a data scientist on your team who's building in a notebook. But that usually is just looking at the raw history of the thing. What can you learn from that to understand about what's going to happen next? From there, that forecast usually gets picked up and goes through a couple rounds of adjustments with business stakeholders on the team. So first, there's just raw external adjustments. This is typically something like the economic forecast for a given industry, if people think it might be relevant. After that, there's sort of more internal strategic focus adjustments that are made. So when you have something that's not going to be reflected in your history that is changing in your business, like maybe you've grown your sales team and you expect them to sell 10% more in the upcoming quarter, you want to be able to fold that in because you won't be able to pull that out from the history alone. And then finally, everyone gets together, sort of stamps the forecast ideally, and that becomes the consensus forecast that you guys then operate around. When we look at this, we'll talk a little bit about our experience with a lot of the different steps here, but we focus a lot on the statistical forecast. because we find that it affects everything downstream, and there tends to be a lot of improvements that are made that are easy to measure and quantify.
Yeah, so hopefully that kind of level sets. We wanted to kind of give you a baseline, and I'll jump in at points. Ben's certainly the expert from a demand and modeling perspective, but I'll throw in some thoughts around the people and the business side of the process and how other areas of the company are interacting with the whole process. So with that, we'll shift into kind of our perspective on statistical forecasting.
Yeah. And so, once you look at that process, the next question that comes up is, why invest in forecasting? There's a million other places in the business where you can put money and attention. So what's the value of focusing on forecasting in particular? And there's really three pillars that we see come up when somebody invests in forecasting. The first, and often the most urgent and easiest to measure, is savings. So decreasing overall inventory costs and improving the turns on your inventories just lets the business run more efficiently. It helps you have more cash flow, saves you money overall, and can often be translated to like a really tangible ROI figure. But there are a couple of other benefits that run alongside it too. Another one that we often see comes up is just the ability to maximize all the opportunities across your supply chain. This happens on both the customer side. So for instance, like you can avoid an out of stock event, right? You always have your product in the place at the right amount where you need it if you're running accurate forecasts, and you never have that sale that you could have gotten or not on the shelf. Conversely, if you're not directly selling to clients, you're still going to be working with your suppliers, with the other people who flow up or down your supply chain. And the more accurate forecast that you can provide for them, the better your fulfillment and relationships are going to be with them, which makes everything smoother and is going to increase the overall efficiency of your partnerships. Finally, one that I think will be of interest to probably some of the people on this call, there's opportunities for automation. So forecasting can be a really arduous process. It takes sometimes really talented stakeholders, huge swaths of time to pull everything together, validate it, verify it. And while we never really advise fully pulling everybody out of the loop, we do think it's useful to have people who are auditing and adding their perspective. A lot of those tasks can be automated to give time back to focus on the important questions in the forecasting process instead of just the basic activities of pulling together the initial forecasts. So
yeah. Oh, sorry, Ben. I was just going to say, like, as you think about, as we talk about this, and as you think about improving those baseline forecasts, that last part is really important, right? It's important not to be disconnected from the people that do the work today, embedding the change, whatever you decide to do from a change perspective, and in experimentation with them so that they understand how things are evolving and how you're changing those forecasts. Because I've seen companies do that in a vacuum, like on the side through IT or data science, and it's a miss because part of the process is trusting the data. And if those folks that do this on a daily basis aren't involved, then it definitely makes it harder for them to accept the changes that will happen as a result of this. So just thinking about that and how you bring people in, the result will be demand planners have more time to focus on the more difficult problems rather than on tweaking things that maybe don't have an impact or as big of an impact. So important piece of this.
Yeah, I mean, ultimately, a forecast is only valuable if it gets used, and the business people have to be the one to do it. So these three pillars, I mentioned before that statistical forecasting is often where we initially focus. In our experience, you can realize all three of these things starting and refining that area. But I do want to quickly talk a little bit about the adjustments portion as well before we dive into how you can actually drive those improvements to the forecasts. And what I really want to call out here is a ton of value can be driven just by creating a framework to actually measure the impact of your adjustments, which is more difficult than it sounds, right? Because you often have a lot of different teams in the business who have their own method for estimating how much they think they're going to increase sales, right? Or the impact they're going to have on the overall supply chain. And it's really easy to get a little disorganized, have them throw the adjustments, thread them in, stamp the forecast, and pass it through. And in our experience, you have likely some chains in the adjustment process that might be doing more harm than good. So one of the nice things about forecasts is they tend to be really measurable. You can hold them, you can compare them against what's happened in the past, and you can see what's more or less accurate. So when we look at adjustments, the lowest hanging fruit and where we tend to drive the most immediate improvement is just putting a forecast value added framework in place where you're selecting metrics and actually consistently tracking them at every stage of the process to understand, is this actually improving the overall process? Because the good news is if the answer is no, it's not, you have a process that you either don't need to spend time on, you have a process that you can examine to see how it can be improved. If it is, you can invest in automating it or taking some other actions. But in general, just removing the adjustments that are actually adding uncertainty to the forecast because someone's guessing at what's going to happen and they're not quite sure, it can often provide a measurable increase that doesn't even have to touch the actual forecasting process or methodology itself.
Yeah, and I'll just add, like, it's a really important point and something that Ben and the team have taught me since I've been here. In my former role, we were always trying to figure out how the input, how I was involved in commercial sales, right? So how was sales impacting the forecast from a demand perspective? And, they're involved in the S&OP process. They have demand planning meetings. But I think then we're never really sure of how their input impacted the end result, right? You get that consensus, et cetera, but the detail of what they did and what impact it had was never really that clear to them. And so then we spent time trying to figure out how to get to a sales call. Like, what was the sales call, and compare that to the demand forecast, right? Which is really kind of a waste of time if you think about it, because you want to try and get that into the forecast and then give them input as to what that did to the forecast, right? I think if you involve the sales and marketing teams, and I get that it's not that easy, but so they understand how they're impacting the forecast and when their inputs improve and when they don't move the needle, I think it would be valuable information for them so that they can refine their processes as well, right, upstream, so that you're getting the best possible inputs. Thanks, Ben.
Yeah, thanks, Tammy. So that reflects, our overall view of the different components of the forecasting process. And now we can dive a little bit into more tangibly, how can you leverage technology and what kind of considerations do you need to have on your mind if you're going to actually drive some improvements to processes like this. So starting off, I want to talk a little bit about why this isn't a solved problem, right? Like, demand forecasting is something that's, people have been working on for decades and decades and decades. There's huge companies who invest significant amounts of money in forecasting approaches. And still, this is a problem that every company wants to improve on. And broadly speaking, there's three things that you need to consider in whatever approach you're going to take. The first is just that these are challenging series to model. This little chart I've included here is actually pretty illustrative of this. So you can see those black lines, if you're taking those to reflect the actual sales, you've got a lot of periods where you sold nothing. And then you have a couple spikes where you sold like one thing or two things. But you have something that's pretty erratic. And if you're trying to measure this in terms of the error, you might have a forecast that looks like this blue line, which from a smell test, if you looked at that, you would not think is a well-performing forecast. But in actuality, if you're trying to measure the error, if this is taking swings like this erratic series, there's an opportunity for it to hugely miss on any single period. And so the error rate's going to look super high. So you end up with a lot of situations like this, where the series itself is really hard to forecast, and you'll have something where it seems like the best option is just to forecast like 1 all the time, or maybe even 0. And making sure that you have an approach that's going to accommodate for that weakness with how erratic the data can be for this use case is really, really important if you're going to drive value at scale. You can improve some of your more consistent SKUs and locations a little more easily because you're going to have a little more consistency in your data. But making sure that you actually have a metric and a framework that allows you to measure these harder to model series is really essential. And how difficult it is to predict something like that is sort of the heart of why there's so many forecasting discussions around this. The other two items are a little quicker to talk about, I think. Second is just it's difficult to scale these processes depending on your business. Supply chain demand forecast might be a couple hundred SKUs across a few distribution centers, or you could be a grocery chain where you're trying to forecast, a million different cuts of something in a bunch of different stores, and you need to order every couple days in order to keep things fresh. So the considerations of SLAs, like how much time it takes to actually turn around the forecast, is something that needs to be considered when you're basically laying out your initial approach, because it's easy to build a really, optimal approach that doesn't scale at all. And then you can't actually put it in the hands of the people who need it at the rate they need it, and you can't realize the value of it. Finally, this is a drum that we're going to keep beating, but the painful to integrate portion, ultimately data scientists can maybe make really great forecasts, but demand planners are the ones who actually have to translate them into decisions in the supply chain. We've seen plenty of instances where somebody makes a great model in a notebook, and then it's not easy to roll that into the actual system that's coordinating with the inventory itself, which makes it really hard to adopt and leverage the forecast. And so you end up with this tragedy of something that's theoretically really valuable that nobody's able to pick up and use.
Yeah, and you see it a lot with companies where, and we'll talk about this a little bit later, maybe the project is IT led and it's in a vacuum. And then how do you just integrate it with the process that then leads to the next step in the process? And so we'll talk about that a little bit more as we move on, but it's just a really important piece that we see misses on quite a bit.
Yep. We'll continue to get just nerdier and nerdier the deeper we go into this. But so now we get to talk a little bit about, assuming that you have decided on the scale you want, you know how it's going to integrate, what can you actually do to improve the quality of your forecasts? And from a very broad level, there's really two things you can do to improve forecast quality. You can use different models and techniques to basically generate the forecast. So, I mean, ultimately, you're using, some kind of statistical equation, some kind of machine learning model, whatever it is, and you're asking it to interpret the series and give you an estimate of what's going to happen next. And especially, across the last few years, there's been a huge expansion in the number of viable techniques and the kinds of things they can accomplish in terms of model selection. The second option is you can bring additional information to your forecast. This is the idea that if you could understand what was going to happen in, the stock market and what's going to happen with unemployment and what's going to happen, in specific like shopping behaviors in the regions that you're in, each of those things theoretically contributes to a more valuable forecast. In our experience on these projects, customers often really focus on trying to bring additional information to their forecast long before they've exhausted the potential lift they can get from improving their modeling options. They both have a place, and we've certainly seen cases where you can bring data to bear that's going to make your forecast better. But you run into two problems, which is one, you have to be able to predict that thing in the future. So if you're able to pull in like your promotional schedule and you know exactly when those are going to run, that can be an incremental improvement to the forecast that you have control over. But if you're going to do something like try to account for economic variables, you're taking a different forecast and layering it into your forecast. So maybe you're realizing benefits if you have it right, but you can often end up compounding basically the amount of assumptions and uncertainty that you have in the forecast overall, which can lead to actually worse performance. So overall, both have a place, but again, we really like to start focusing on the modeling. That's where we've seen more significant impact that's easier to scale and maintain.
Right. And one thing Ben and I have been talking about is really how, like in my role, I always thought, my former role, I always thought like it would be great to have a data scientist on my team or embedded in my team, right? Like we were doing a lot of data and analytics and we would reach out to them and pull them in for a need, but having them embedded in the team, and this feels like a really good place for that, right? Because like if they knew the process and they could understand and help with the data science and understood what they were trying to focus on, it feels like you could really get the most bang for the buck. And so, they could still be a part of the COE or the data science team from a programmatic perspective, but can you, I guess, Ben, maybe just from your perspective too, can you embed data science into a process, and is that valuable for kind of iterating and getting there faster?
Yeah, I mean, in our experience, when you have a technical stakeholder who's more actively paired with the business, that is when you drive the best results on this. Like there's a lot of trade-offs in forecasting. Like even when you're looking at something like trying to improve a model, right? You might have one model that performs better slightly overall, but maybe it's a different mix of series that it performs well on, and that's really impactful in terms of what the business is trying to accomplish. And so in a vacuum, a data science can optimize for metrics, and that's great. And we do recommend, that as a general approach, but getting the actual understanding of what's important to the business, what needs to be considered, and like having them be able to operate as a little more of a unit is where you actually get forecasts that people trust and buy into and drive impact.
Yeah, absolutely. Yeah. And it seems like we had a customer who had that, and it seems that it really did drive a lot of value to have that data scientist understanding and tweaking for the variables that were important for that customer, right?
Yeah, I mean, the overall quality of the forecasts we will deliver were better because of it, and also just the path to adoption, right? Where once they understood that the forecasts could drive a lot of improvements in value for them, there wasn't the secondary process of going to the business stakeholders, walking them through what was done, making them understand like, oh yeah, we're missing here, but here's why, because they've been embedded from the start, so they were able to actually operationalize and pounce on the opportunity instead of having a whole secondary effort to push it forward.
Right. Yeah, efficiency wise, it makes a lot of sense. All right, so now we'll move on to what Ben really loves, the pros and cons of modeling approaches, where I will have very little to say.
Yeah, this is the good. This is the good stuff. But so there are more than 3 overall families of modeling approaches, but these are the three that we most often consider and work with. And there's pros and cons to each of them, and there's really strong feelings in the space about which ones are correct. Being a little agnostic in our experience tends to be often helpful. So just to give you an idea of how each of them can contribute, statistical forecasts are sort of the baseline. They're kind of the oldest methodology for it. And there's a lot of reasons that they're still in play. They're simple and they're consistent. They're usually really fast, and they're easy to modify and understand. They're usually not taking wild swings. You can go back and you can break down precisely like basically how it's interpreting things, the math it's doing, and then what it's spitting out on the other side. So that's especially useful if you think back to like the series I highlighted earlier, that's really hard to predict. That might be hard to predict with any method. So having something that just does it quickly and in a consistent way, if it has a similar error rate that's going to be high as anything else, there's a lot to recommend that approach. In terms of the cons, statistical forecasts, for much more complicated trends, there's often a little bit of predictive power that gets kind of left aside. When we look at some of the other options, they have a lot of opportunities to learn more nuanced long-term trends that might get kind of washed out in some statistical methods. And secondly, it can be a little difficult to fully account or integrate external factors into a statistical forecast. You generally have to be able to sort of quantify it yourself to layer it in. Whereas some of the other techniques, you can sort of just provide it alongside it and let the model itself figure it out. And that's going to save you, some mental bandwidth in terms of knowing what's valuable or not. Machine learning algorithms kind of exist on the other side, in my mind. They're capable of driving really high accuracy, and they're the most sort of fiddly and customizable. They don't necessarily natively know how to take in time series. So under the hood, they have to basically do a bunch of feature engineering, and I won't go too deep into the detail of that here, but the headline is you have a lot of control over what you can basically push the model towards caring about. So if you have a strong understanding of what might be driving the business, you have time to really tune and invest, you can get a lot of predictive power out of these. The cons are sort of contained within that. It can be really compute intensive. It often takes a lot of time to get to that optimal tuning point, and it requires a good degree of attention. The last sort of series or modeling type I'll talk about is deep learning, which is a little more recent in terms of being leveraged so actively within the forecasting context. So deep learning I see is sitting a little bit between the other two approaches. It can drive high performing results at scale, and it's particularly able to do that for time series because there's so much inherent similarity between different time series. So deep learning often is a technique where you need thousands and thousands and thousands and many more thousands even. You need like big data to be able to pull out insights. Because time series have so much in common just based on the shape and the fact of what they are, you can get high quality deep learning models with smaller sets of forecasts. The cons there, they're difficult to tune as precisely. And it does still require some scale. If you want to run, 100 forecasts, deep learning is likely not going to be the best approach. So that's sort of the high level overview I have of how I think about the three different buckets.
Great. And so what we're all here for, right, is to answer the question, what is the best forecasting model, right? I know you're all waiting anxiously for the answer, and it's just over the horizon. There isn't one, right? There's no silver bullet. And Ben will talk through some of the models or some of the series that he's working through, but it's kind of interesting. I've learned a lot over the last few months as I've talked to Ben about how to forecast and how to get really good at demand. And I think there are some really great possibilities in the work that he's done. So without further ado, we'll talk about data profiling and some of the things that Ben and team are working on here.
Awesome. Thanks, Tammy. One of the dirty secrets of data science is so much of good data science is just doing good data engineering and getting the data organized and making sure that you're modeling on the right things. And forecasting is no different. When you think about what kind of model to use to drive the best results, the answer is gonna invariably be, it depends. And one of the things it depends the most on is what does the actual shape of the data you're trying to predict look like? So we often approach this starting with data profiling, just taking all the series that you have and trying to bucket them to understand basically like which ones are easier to forecast. It might be amenable to certain techniques, which are going to require special attention or alternate techniques. The exact way that you profile and cluster your data can vary a lot depending on your business and the kind of customer. So oftentimes people will have velocity classes for their products, which is another good way to potentially start profiling. But to give you a generic overview of the kind of things that you need to typically be aware of, there's sort of 4 series types that we think are most important to account for in some form or fashion. The first is erratic, right? So these are like high volume, high variance series. So you can see this very beautiful graphic that we've been able to provide. The volume's pretty high on this. It's moving hundreds or thousands of units in every period. But how many hundreds and how many thousands is kind of all over the place. So that's something where, there's a lot of opportunity to get it right or wrong. And you want to make sure that you have a technique that's going to accommodate and count for that. You can't like cleanly pair it with one of the 3 I talked about earlier to know what's going to be best, but this might be one where doing something like looking at a machine learning algorithm to start, right? There might be some more complex pattern to the trends, like something that looks like noise at first that a model can help you figure out. That's going to help you drive more accuracy here. The second is a reminder of the chart we looked at earlier, a good old-fashioned intermittent series. These are very difficult. These are products that are slow moving, and they have low variance. You sell one or two every once in a while. Coming up with a forecast that's going to be able to handle this really well is really difficult to do. But the good news is your intermittent series are often not going to be the major drivers of your business. And one of the other advantages you get from breaking out your series like this is you don't have something like the accuracy profile of your intermittent series affecting how you view your overall forecast accuracy, where you end up optimizing for improvements to this very small product when you could be optimizing for the total product catalog. So intermittent, looking at this one as an example, you can maybe solve that by just ordering a few every month. The need for a sophisticated forecast is much less significant. Third, you have lumpy series. These are low volume, high variance. So similar to erratic, they're spiky, but similar to intermittent. They're not necessarily the major drivers of your business. So again, you want to spend a little time here trying to get them correct, but the sum total of your lumpy series or SKUs often might, pale in comparison to the impact of just a few of your erratic. So you can split them out and make sure you're treating them separately and appropriately. And finally, you have your smooth series. So these are your high volume, low variance series. These are like your velocity A products that tend to, sell hundreds or thousands every month in a more routine way. These are the easiest to forecast. Like you're typically going to see the best results on these smooth ones. They're often also the ones that are harder to drive as significant an improvement in the forecast because a lot of techniques are going to be able to pick up on them. So there's a trade-off there, but typically if you're not getting your smooth as good as you can, you're leaving a lot of value on the table. So that's, again, it's going to vary by your business, but the 4 generic kind of series and kind of why you need to think about and treat them a little differently if you're going to ultimately implement something that's successful and accounts for all the factors that you want to.
So Ben, just as you think about the companies that you've dealt with over the years, what do most companies do in your experience? Are they applying these different profiles and segmenting their products, or are they kind of just blanket applying one to all?
Yeah, so that's a great question. I think they tend to apply one to all, and they'll often track like by velocity class or something. But in terms of actually applying discrete methods to the different buckets or series, it's often way easier you have your inventory system or whatever, and it generates a baseline forecast, which is often, a single method, and it gets applied across all of these. So, 2 of, I think, the lower hanging fruit mistakes that we see companies sometimes make in this process is using only one method when there's all these different use cases that you want to be able to account for. And the second is commingling how you measure them, right? Like making sure that you actually understand if you're driving accuracy for the series that really matter versus a series that matter a lot less. That's a way your statistics can kind of lie to you, and you can end up optimizing for the wrong thing and have a process that doesn't drive nearly as much value.
Right. And I know we'll talk about this in the next section, and we're getting close to our time. We've got about 10 minutes, and we've got our next slide is around why do forecasting efforts fail, and we'll talk a little bit about like the business impacts of trying to change these things too, which I think is really significant, particularly in this area. So we'll go ahead and move on to the next slide about failure points and change management.
Yeah, so this is an area where I think Tammy and I have a lot to say, but I talked at the beginning about why, or like, I've seen a lot of forecast processes work and I've seen a lot that haven't. And there's sort of 4 trends that we often see when people are trying to improve their forecasting processes that prevent the transition from being successful. The first I think of as not embracing an analytics mindset. So forecasting, again, one of the great advantages of it is it's very measurable. And you have to make sure you're measuring the right things, right? Like I mentioned earlier, you can't be valuing your intermittent series at a similar scale as your smooth series, things like that. But if you are measuring it properly, you want to create an environment where you're trusting the overall process and those metrics not trying to improve every series and edge case. And what I really mean by that and what I've seen happen is forecasting is often focused on misses. So people will go through a cycle, they'll generate them, and then a huge amount of the time is focused on picking back through them to understand why did we miss on this, or like what drove the error, which can be useful as long as you're using it to actually identify broad trends that you can improve. But it also means that people are often a little afraid to do something where they might miss on a series where historically they've done well. And that risk prevents them from moving forward with a process that might overall improve the quality of the forecasts, even if not every single forecast improves. So the willingness to commit, even when there's a little bit of that uncertainty and risk, is something that we've seen hold some stakeholders back.
Yeah, and it's definitely an area I see, right? Like everywhere, right? You're trying to get to the minute detail and explaining the mess, right? And it's important to get better overall from whatever it might be, right? Fill rate, OTIF, whatever you're looking at as the miss. But in the real world, and in the real world, every product matters to someone, right? So every SKU ends up mattering to somebody. And so as you think about improving the overall process, not every series, it's going to have to be something that's understood at the top of the organization that you're rolling it out in, right? Because you have to protect the people that are doing the work from having to revert back in order to explain what happened, right? So I think there's some balancing there that needs to happen if we want to move forward in some of these different mindsets around forecasting. So, all right.
Yeah, that's the second one, which we touched on a little bit in a couple different parts of the presentation, but is focusing on the wrong metrics. So, there's a lot of different ways that you can measure a forecast in terms of the performance. And there's a couple like classic standard industry metrics that are really commonly used. So like mean average percent error, or MAPE, and bias are the two big ones that people tend to talk about. But you need to make sure that when you're actually trying to understand if the forecast is improving or not, that those metrics reflect what you're really trying to accomplish. And I think the supply chain demand planning is a really interesting use case, because what MAPE really looks at is in a single period. Did you hit or did you miss? And so you might look at like every day and have a high MAPE. But if your horizon to fulfill orders is 2 weeks, it doesn't actually matter if you missed a bunch on the individual days, as long as the 2-week roll up is good enough. And we've seen lots of instances where it's easy to get fixated on the baseline statistical measurement, and they're not folding in sort of like what is the actual business process that needs to be considered. And they basically optimize for the wrong thing. And then they have a forecast that performs much worse than it should, because they're trying to get every single day right, when in reality, if they could get the larger spikes, they would provide more value. So
yeah, this is one where it's really hard, right? Like just in terms of, as you think about, I think about it from a sales lens, right? The customer, right? Every day matters, or at least a week, or whatever it might be, right? So really, really difficult stuff to figure this out. And so I think one of the things that I would always suggest is remembering to include the business in the understanding, right? So marketing, finance, sales, whoever it might be, as you move towards change in these areas, it can be done through S&OP meetings, right? Individual demand meetings with sales team members. I think one big thing is it's going to take time. Things are really hardwired in supply chain from a demand perspective. I've heard from my demand friends that not many have figured this out, right? Like it's in all industries. There's a focus on improving forecasting, demand, supply chain, all of it. So it's like baby steps, but it's important to bring everyone along and not just one group of people. So so that you're getting buy-in across the end-to-end supply chain, not necessarily just one piece of the supply chain. So
Yeah, that's a great lead into the next point, Tammy. It's almost like we planned it. But the other or another common mistake that we commonly see is focusing just on the technology aspect of this, which I know I walk through a bunch of models and approaches, and I understand how that can happen. But it's common in a lot of companies to have kind of a hub and spoke model for like IT, where they build capabilities and they push them out to different business units. And with forecasting specifically, right, where there's all these different business considerations, and there's a lot of nuance in terms of how demand planners have to work with it and process it and even fit it into a bunch of other systems. It's really easy to fumble that handoff. So like the hub and spoke, the idea of being able to just provide flexibly to all these different business units is valuable if done well. But we found that, for these sort of more speculative predictive exercises, it's especially fraught to kind of have that integration fail to take.
Yeah, and this is an area I'm pretty passionate about in terms of IT versus business running projects, right? Like it needs to be a collaboration. It needs to be solving a business problem. It needs to come from the business, right? So the business has to want it. They have to understand it, and they have to be involved in solutioning it. I think it's really difficult to drive adoption, but more importantly, trust in this area. Like this is a really big trust area. And I think demand planning people are stressed, right? Like if you think about their job, they're the middleman between sales and marketing and finance and operations and manufacturing and purchasing. Like they're always disappointing somebody, right? So like their job is really hard. And so you get to be a bit gun shy taking a risk on something unless you've got people around you that are helping and unless you understand what's going on, right? So like that IT kind of business connection here, I think is really, it's just critical because of the situation that this group of people is in, and that's such a big impact on the business and the entire supply chain. So this is one that I love and really love to promote, that it can't be IT driven. The business people have to be involved solving a specific business problem.
Yeah. And if you don't do that, I think you can run into sort of the fourth thing that we often see, which is giving up too early. So analytics processes like this, it's a cliche, but it happens to be a true one. They're a journey. And when you start doing something new like this, there's going to be some toe stubbing that happens along the way, where you are going to try a couple models probably that are going to come back with results that look cartoonish, right? But if you stick with it and you're willing to basically iterate quickly, and again, trust the metrics that you've defined, you can get to a point where you overhaul the process and you're able to actually kind of raise the quality of forecasts across the board. Like Tammy said, it's really tough to be a demand planner, and I understand how scary it is to take on a tool that maybe potentially makes your job harder for a little bit. But having the total organizational buy-in for people to keep pushing is how you get to, these 20-30% accuracy lifts that drive really big bottom line value for the companies that take them on.
Yeah, huge impacts, right? And then the other thing I thought about when I thought about this giving up too early, just an analogy, right? So I don't know if any of you have ever been through an ERP implementation. I'm going to bet some of you have. And you don't give up when that doesn't go well. And I can't think of an ERP implementation that went well in my lifetime. So you keep going, right? You get it right. And so why is this any different, right? Like, why do we stop here and revert back? And why can't we push forward as a function and a process and an industry to get it right? Like we do with the ERP systems, right? We won't throw them out with the baby with the bathwater, as they say. So let's not do it here. So that ends our prepared remarks exactly on time as well. And so with that, I think what we would do is turn it over to our moderators around Q&A, if we have any Q&A.
Yes, thank you guys so much. This has been really wonderful. I've been furiously taking notes. So we do have a few questions in the chat. So one of the questions is, are there any specific data sets that you should consider to use? And then just as a reminder for everybody on the call, you can use the chat over at the bottom and write in any of your questions. I think some of you might have a challenge if if you're outside of the NewSat organization. And so you can also come off of mute and ask your question that way as well. So whatever is easiest for you all, we'll just try to get it together. So anyway, guys, sorry. What are the specific data sets that we should be using?
Okay, great question, and a really common one as well. The answer is, of course, it depends. But to add a little more specifics around that, like I mentioned earlier, the most important consideration, I think, when you're looking at like external and other data sets to leverage beyond just your history, is how confident you are that you can actually predict it. Because if you don't feel like that forecast is going to be strong, you are just compounding the uncertainty that you're putting into your forecast. So with that in mind, the data sets that tend to drive the most value are ones that are incredibly consistent. So there's not a lot of potential fluctuation. Those don't pose much risk because they're probably not going to drive that much change in your forecast, but they can offer some incremental improvements in helping like identify a seasonal trend or something. Alternatively, things that you can control. So I used the example of promotions earlier, and I think that's a really great one. If you have like a business who, does like a lot of sales events, they often seriously impact demand. And if you are able to keep your calendar up to date so you know when those surges are coming, it's going to do a lot to improve the overall quality of your forecasts.
And then lots of people, so I would say, and I've been also done this to Ben. I'm like, what about weather, Ben? And I hear it a lot. I've heard it a lot in my lifetime in terms of how weather impacts. And I think, as business people outside of the demand realm, the supply chain realm, we are like, well, weather impacts the forecast, right? But what can you actually react to, I think, is one of the things that we're learning, right? So you can bring in weather, but you have to be able to react quickly enough to the weather to make a change along the line, right? So it's not just the forecast. It's like, can you actually impact supply or demand based on that short time frame of a weather impact, right? And so I know when I talk to demand planners about weather, they laugh and say, yeah, whatever kind of thing. So Ben, I don't know if you have a perspective on that one.
Yeah, I get cranky about weather forecasts, but I mean, there's definitely places for weather to be included, and it is really common to try and consider it. If you're looking at like a broader kind of like climate trend, right? That's something that you can forecast, and like that might have an impact. But it's funny to think about using it in like more lower level ways as a forecasting add-on, because how many jokes in your life have you heard about the weatherman not being able to tell you what's going to happen tomorrow? And so then you take that and you try to use that weather prediction to guess what's going to happen, and you're at their mercy.
Awesome. So I'm going to skip around in some questions here. I know we have a lot in here, and just so everybody knows, if we don't get to all of them, we will definitely follow up. I'll have Tammy and Ben just write some things up for you and make sure we get you a response. So can you guys comment on the agility, cost, complexity of the models, scalability between vendors like Blue Yonder, and maybe a custom build, in a public cloud platform?
Yeah, for sure. So ultimately, if we're talking about the models themselves and kind of like the scalability and agility of those, building custom models on a public cloud platform is a lot more agile and, in our experience, a lot more performant than some of the like larger kind of out-the-box providers. And when you're thinking about why that might be, you have to consider everything that Blue Yonder does. As an example, right? Like that's a platform that is responsible for a lot of other components of the supply chain, and that is where a lot of their focus is in pulling those together. But in terms of making the best forecast that is not being sold en masse and can be kind of tuned for your business, that is where we have seen a ton of success and driving improvements is going in against more sort of white label approaches. And then, some of the things that I talked about earlier in the presentation, like bucketing the data in different ways and experimenting with different approaches for those different buckets, you can drive some substantial improvements over some the competition.
And then Ben, maybe you could talk about how then you get that back into like a Blue Yonder or an O9.
Yeah. So, and that's a great point, because ultimately the goal is not to displace Blue Yonder. Like that is a tool that you need to do, 20 other things in the business. And back to the idea of you want to make this as easy for the demand planners and the business people to embrace as possible. Those tools are often what they're used to working in. It's where they actually like approve and manage the forecasts that tie into all the other systems. So, for hitting kind of the best balance of like the scalability, agility, performance, and change management, building your own custom like cloud deployment and then integrating that and feeding it in to existing larger systems is our typical approach. A lot of them have APIs and things to help you ingest those custom forecasts in.
Wonderful. Can you guys help us understand about how long these types of solutions take to implement?
Yeah, so there's a couple stages to a project like this. The first is just building out the actual models themselves. And in our experience, that can be done relatively quickly. If you have a good, solid framework for how to deliver it, and you kind of know the different techniques that you want to experiment with and have a smart way of iterating through them, we've seen that you can drive pretty substantial improvements, in a few weeks. Now, getting those results to the point where they are optimal, right, is a whole different question, and that can range from a few weeks until everyone's comfortable to a couple months, depending on the value of continuing to iterate and how much you're actually trying to sort of perfect the modeling approach. The other component is, of course, the actual integration of the business process. So similar to what we said before, you got to be able to feed them into Blue Yonder. You got to be able to do whatever it is where you can make them accessible and actionable from the business. And that can take a few weeks as well. And it's going to vary widely based on what your actual format for consuming the forecast is.
I think the one thing that I've learned over the last couple of months being here is that it's not years, right? It's much smaller amounts of time and incremental improvements along the way. So I think that's get to something relatively quickly and then just continue improving and iterating on that.
Great. So can you guys provide some directional understanding of outcomes you've seen as a result of driving improvements to existing demand forecasting processes?
Definitely. So in terms of raw accuracy lifts, we've seen, in the neighborhood of 20 to 35% taking some of these techniques and applying them. That's focused sort of on bottom line make and inventory optimization. The other thing that you can drive through kind of taking on these initiatives and focusing on something that's a little more specific to your business is you have the opportunity to thread in some strategic wins as well, right? Like if you are really concerned with maximizing fulfillment, we've had some customers that way in the past, you can ensure that not only are you more accurate overall, but like you're erring on the side of a little over ordering instead of under ordering. And so it's not just the impact that you can get from the raw accuracy amount, which tends to be pretty significant. It's also kind of consolidating the overall strategic direction naturally into the forecast.
Great. All right, guys. Well, I know we are at the bottom of the hour here, and I do want to be respectful of everybody's time. Thank you so much for joining, and thank you, Tammy and Ben, for putting together such amazing materials. It's been really, really educational, and I know that it has spurred a lot of ideas in my head. I hope it did the same with all of you. So Tammy and Ben, do you guys have any other closing comments?
Just thanks for attending. Thanks for the time. We really appreciate it, and happy to help with you any issues you have or questions you want to have just to have a conversation, we're here. Ben and I think I'll just, here's our contact information, right? Just reach out to us if you have questions. Ben?
Couldn't have said it better. Don't be a stranger.
Awesome. Thanks, everyone.
Thank you, everybody. Be on the lookout for your LinkedIn badges, and hope you guys have a good rest of your day.